Hello, this is Phil Thomas at New Era Systems. Today I'm going to test two MCL 3200 amplifiers, two Mytek up converters, and a redundancy switch that we manufactured ourselves. So I can accomplish a lot in a single test. Let's look at the components that I'm going to use. The first thing you can see is the two amplifiers. Above them I have two Mytek 70 MHz to KU band up converters, and on top I have the redundancy switch. On the other side of the bench I have a frequency generator, a spectrum analyzer, and an HP power meter. All of these components are going to be used at the same time for this test. In real life at a teleport, when you're producing critical programs or critical uplinks, you need to have redundancy in everything. If the amplifier goes down, if the up converter goes down, then you're in severe trouble. So all teleports have a redundancy of some sort, and that's what I'm going to demonstrate today. Let's look at the back of this stack of equipment and see how everything is cabled and how it fits together. To make it easier to demonstrate, I've left most of the cabling off. I'm going to attach it in a few moments after I finish this explanation. These two twist flex waveguides are coming from the transmit port of the MT3200 amplifiers, capable of generating up to 400 watts of KU band output. They're being fed into this switch. It's called a baseball switch, and it directs the output from this one, for example, out to here, or from this one out to here. And so that's really what a baseball switch does. It's able to deflect the output of an amplifier. Let's look more closely at the back of this amplifier. This connection here goes up into the redundancy switch, and it monitors any alarms or faults. So if anything happens to this amplifier, for example there is a crash, a hard shutdown, it tells the redundancy switch. If there is an alarm could be something much simpler. For example, I expect these amplifiers to put out 150 watts. So I can set an alarm. If that drops below, let's say 140 watts, it generates an alarm. In a real application at a teleport, this, for example, would be going straight out to the antenna. But because I don't have an antenna, I put a dummy load onto it, and I'm going to monitor this on the spectrum analyzer. And so the spectrum analyzer will see what the antenna will see. This other one is simply a dummy load, and this is going to take the output of the amplifier that is working in the redundancy mode, not currently connected to the antenna, but waiting until something happens to amplifier number one, and then it would take over whatever's coming out to here. It would be switched and it would go straight out to the antenna. Boy, that's not a very good explanation. So these are the two up converters. I'm going to connect 70 MHz input to there and there. The output, which of course is in KU band, is coming here, and it's going into the back of the HPA. This cable is connected to the baseball switch. So when the redundancy switch says change the input, it flips this switch, and now the input supposedly was coming from here. The switch flipped, and now the input is coming from here, and it's coming all the way out, and it's going out to the antenna. So now let me get to work. I have to cable all of this, I have to turn them on, run them for a while, make sure that there is no gas in the tube, and then we'll bring them up to about 100 watts, and I'll start the demonstration. I'm just starting to bring these amplifiers up, and there is one thing worth noting here. If you look at the redundancy switch, it's showing a fault. It's showing a fault for both amplifiers because they're not yet online. A fault is different from an alarm. A fault is a very hard problem. An alarm is simply an indication that something is not quite right, maybe below limits. So in a moment when the amplifiers come up to speed, the faults will go off and both amplifiers will be shown as functioning, at least as far as the switch is concerned. Both amplifiers are in the middle of their warm-up delay of approximately 6 minutes. This brings the tube up to temperature, and then it will allow us to turn on the transmit. Till that time we just have to sit and wait. Both amplifiers have been through their warm-up phase, and they are now ready to start transmitting. You can see, looking at the redundancy switch, the fault light has gone out, indicating that everything is okay as far as that switch is concerned. They're not going to transmit anything at the moment because the up converters are still not turned on, so the amplifiers aren't even getting any drive. The amplifiers have been running for about 30 minutes. The tubes have come up to decent temperature and speed. So what I've done, I've raised the output on the top amplifier to 100 watts, the bottom amplifier for just over 50 watts. In real life you wouldn't do this. You want both amplifiers to be running at almost exactly the same output. The reason, of course, is that if one of them dies and the other one takes over, you don't want to have a sudden shift in power. That would drive the knock at the satellite operator crazy. But if I did that here, you wouldn't see the difference once we switched from one amplifier to the other. And so what I did, I made them just about half the power. And then it will be very clear when one switches exactly what has happened. The spectrum analyzer is showing what the antenna is receiving and what the satellite operator knock is seeing. And so when I switch, you're going to see a difference immediately on that. Is going to drop from approximately 100 watts down to 50, 60 watts, somewhere around there. I've got two ways of triggering this to go into alarm. One way, of course, is just to flip the switch on the amplifier to an off position. I don't want to do that. You never want to do that with the TWTA. It could damage the tube quite catastrophically. And so what I'm going to do, instead, I'm just going to go to the up converter that's driving this top amplifier, and I'm going to take the transmit off. So there will be no drive coming to the amplifier. The RF low alarm has been set at 91 watts. And so immediately the alarm should trigger the switch to change the output to the bottom amplifier. So let's see if this works. Okay, I'm going to press the mute. There it is. It switched right away. And now the bottom amplifier, with its 58 watts output, has taken over. Okay, well, that seems to work extremely well. The switch sensed the difference in the output from the top amplifier. The RF low alarm was triggered, and so it caused the baseboard switch to redirect the output from the dummy load directly to what you can see on the spectrum analyzer. In other words, from the dummy load right into the antenna feed. So I'm quite comfortable with this. Everything seems to be working well. Offline I'm going to run these amplifiers up a little bit more and check out the characteristics. But for the sake of this video and this test, I think we're finished.